Dear Mathagony Aunt, do you have any good practical suggestions for teaching bearings that will infuse my Key Stage 3 maths groups? I'm particularly interested in activities for both my low and high ability students. Any suggestions would be greatly appreciated. Thanks, Peter Alper.
Well, Peter, bearings is a subject which really lends itself to a practical approach. After all, bearings are used to find our way around in the real world. There are a number of different activities you can do in and around your school, and these can be tailored to different ability groups. Coombe Dean School in Plymouth are using an exciting approach to teach bearings to both their lower and higher ability Year 8 groups. Tony Biddle introduces his low ability class to the compass points.
What I want to make sure is that they're all confident with knowing the points on the compass. So north, south, east, west, and then north, east, north, west. I'm going to tell you a direction, and I want you to point in that direction. This wall at the front is north, and I want everyone to point north. South, west, east, southwest. Majority are going that way? Yeah? Because that's west, that's south, so southwest. Right, northwest. And what I want you to do is come up and drag a word to where it belongs on the compass. We're going to use some compass directions to find your way around the school. Okay, there's a series of buckets that are laid out around the school with pebbles in them. Okay, on those pebbles are letters, and you're going to find your way to them.
Tony and fellow maths teacher Jackie have created a treasure trail of letters which spell the word angle. There are 10 buckets, but 5 of them are decoys. The children must use their compasses to reach the buckets and find the letters.
Start from the bottom of the arrow, and what you're going to need to do is you're going to need to find the directions using your compass. Each pair needs a sheet of paper. This is to record your letters. Then you're going to have to rearrange the letters to get a word at the end. So we're looking for you to do it as quickly as possible, but it's important that you do it accurately, because if you get lost and you get to the end and there's no bucket, you're going to have to come back and start again. So you need to be sure of where you're going.
Okay, we're just like... We need to go this way, southeast.
Okay.
Southeast, but...
So, do you think we might have gone, because we've got to go 44 metres and we were going southeast. And so that's where we've got. Now we haven't finished because now it says we've got to go south 19 metres.
57. Right.
Right, girls, so you stand over there, don't you? Where have we got to?
Southwest 28.
Okay. At this point I'm going to tell you that you have actually gone the wrong way.
Oh.
No, the time you went wrong was right back at the beginning. You didn't set off to the southeast. So even though you possibly got all these correct afterwards, because your first one's wrong, you're actually in the wrong place. Now, if I asked you to walk towards the gate, what direction would you be walking?
Southeast.
Southeast, good.
Yeah.
So can you walk in a southeasterly direction towards the gate, and can you measure it at the same time to see how far it is? You're now walking in a southwesterly direction. Even though they got lost, they successfully followed the compass south-southwest to find the first bucket and one of the letters of the anagram. Unfortunately, it looks like they've been beaten to it.
You were first?
Yeah, I think we've got the word.
What do you think it is?
Angle.
Angle, well done. So what did you get?
Yeah,
Got the same, well done. What had surprised me was some of the students, the way that in class they're just so quiet, but as soon as we got outside and we were doing something practically, that they were just like completely different kids. They were just so lively and bubbly, and that was really, really nice to see.
Bearings is a good cross-curricular activity linking with science, history and geography. For example, a simple compass like this one can be made in a science lesson. The Chinese discovered this first over 2,000 years ago. They put a strip of metal on a piece of wood and floated it in a bowl of water. We've got a piece of balsa wood and we've got a 2-inch nail. The balsa wood is painted to keep it waterproof. It takes its time, but it always ends up facing the same way. And thanks to that, we've been able to navigate our way around without needing to see the sun or the stars. And Peter, in answer to your question about the higher ability groups, it's good to link bearings with their real-life application. The obvious link is sailing.
Right, now today, in this sort of visibility, we can just see where we're going, and we just follow the channel markers and the lines of anchored boats. If we were coming in or out of harbour in fog, then we would have to steer a course to a particular bearing, which we would get from the chart. So we would refer to the chart, look at the channel, find out what bearing we had to steer down, and that's where we'd go.
It's unlikely that you can take your pupils on a boat like this, but you could get your high ability pupils to work out a coastal route using an ordnance survey map and a compass.
Right, from here you can see we also have an electronic compass, and we're currently steering down a bearing of 298 degrees as we weave our way down through the boats. Yes, we're probably now about halfway down the harbour. Certainly this is the busiest part of it, and about another 20-25 minutes to the open sea from this point.
As long as they stay on a bearing of 298 degrees, they'll reach their final destination. But you don't have to be on a boat to illustrate the practical applications of bearings. Jackie is going to take her higher ability Year 8 class on the same trail around the school. First, she checks her understanding of bearings.
Don't open your packets yet, but when you do, you have inside 10 triangles. On your template, your blank template, you'll see one triangle is already actually indicated, and it says X. You will find the triangle in your packet that is X and put that in this position. All arrows face north, and you see you've got north at the side of your sheet. The one that has a point A on it says 030 degrees from X, 30 degrees from X. So from your point X, make sure it's actually from the point itself, you're going to measure a bearing with your angle measure of 30 degrees. You're then going to find the one that says point B, and that has a clue from A. Point C has a clue from B.
In this exercise, X is the starting point, and pupils have to place a triangle on the shape in its correct position using bearings.
You need to work out what is the bearing of I from. Okay, where's 30 degrees?
30 degrees. There.
Right, now the reason you've got a ruler is that you can actually extend beyond the length of the angle measure, and so point A is going to lie somewhere on that line. Okay, now put triangle A in.
Is it yours?
This actual one is mine, I made this one up myself, but it is adapted from an SMP exercise.
Oh right, it's fantastic. So can you just tell me how you introduced it?
And we've looked before at the fact that bearings have 3 figures.
Right.
We've talked about compass points, and so they're using north, south, east and west. And we've worked on it clockwise and anti-clockwise. So we then presented them with 10 pieces, 10 jigsaw pieces. Now using their angle measure, they then had to follow the clues in each piece from point X to put all their pieces in place. So for
Right.
example, point A is 30 degrees from X. They use their angle measure on point X. They measured 30 degrees. Daniela, can you show us where 30
Having
degrees
completed the activity, they're ready to begin the outdoor trail. They then set off to find the same buckets as the other class. Only this group will be using bearings.
Right, so first of all, we've looked at where our north arrow goes. Just hold your compasses around your necks. Line up the red moving arrow with the arrow on the base plate, and then turn your bodies to follow the arrow on the base plate. Now, all of you should be looking towards me, facing north. Good. Now, if you look at the arrow on the floor, that is our north arrow. That's your central starting point, and all of your first bearings go from this arrow. You're going to go to the 5 different stations. It's not a race. You don't have to run. It's accuracy as opposed to speed.
One was it? It's 23 metres on the bearing.
The fix at that white van, at the end of the white van. Yeah, go. Our next bearing is of 35. And then we go, so it's that way. 28, 29, 30. I think it's down there, the tree. Because if we go 310, just there. It's just about there, yeah. 17, 19, 20. Trick buckets around.
Right, so you think those are trick buckets?
Yeah.
Right, okay.
In fact, I think it's that bucket we're meant to go to.
Why do you think it's that bucket and not that bucket that you've just been
Because
to?
it was directing to that tree.
It was directing to that tree?
That tree, it was.
Right.
Where we were.
So you're going to look in the other bucket and find out?
Yeah, I think we should look
see.
in that bucket
so
to find out.
What you've got?
And this one,
So what have I got in there then?
you've got an E.
I've got an E. Do you think an E is better than a T then?
Yeah.
Yeah, okay. You've done the whole journey there, which was
Yeah.
station 3, and you now go, oh, that's really clever, because I thought you were going to go from there to somewhere else to somewhere else.
Oh.
So every time you're going back to the beginning?
We're going back to the beginning so we know exactly where north is.
Oh, right. So what do you think of this activity then?
I think it's pretty good.
It's great, isn't it?
We've never done anything like this before and it's pretty cool.
Does that sort of like really bring it all to life then?
Yeah, it's one of those subjects that you don't really do a lot of practical, and this is a really nice change.
Right, so you've got your 5 letters, which are L, A, E, G and N. And you get a mathematical word.
Angle.
Angle, well done. It was a great benefit to the children to actually take them outside and to bring maths to life for them. Because so often they're in the classroom, they're looking at their books, and they have real life examples in their textbooks. To actually physically go and carry out a lesson on bearings, which is a very physical activity, it's a very physical lesson, that's going to bring it to life for them, reinforce it, and it will be there now in their heads. Can you all just look at the screen on the board for a moment, please? Right, this is the bearing snooking that you have seen before. The compass on the right-hand side is like our angle measure. So you've got 0, 90, 180, 270. And obviously you've got to estimate the points in between. Josh, can you drag the compass onto the red ball? The aim is to actually pot the red ball into the red pocket. So using your angle measure, you're going to try and estimate the angle, the bearing, that you've got to pot the ball to. Right, so what sort of bearing do you think he's got to pot that ball in? What should he hit it at? James?
335.
335. Elliot, can you type 335 in? You have to make sure it's a 3-figure bearing, don't forget. Right. You could teach the bearings lesson without even leaving the classroom. One way I would suggest is to use an ordnance survey map and to actually use bearings on an ordnance survey map. They can actually use the bearings and they use the idea of distance and measure the distance and plan a route out. So they could use the lesson that we use today and translate that and have bearings, prepare bearings and measure the legs out, or the students themselves can actually take the bearing and measure it. You can also then incorporate the idea of back bearings, that if you go from point A to B, what's the bearing to get from point B to back to point A again?
Well, Peter, hopefully we've given you some ideas to bring bearings to life. Even if your school grounds aren't as big as Coombedean's, you could still use this activity, either in the playground, in the school building, or using an ordnance survey map. You can't always use practical activities in maths, but this is one that is both fun and guaranteed to be remembered by both pupils and staff. I hope you've enjoyed it.